Okay, so let's start. You can hear me, right?
Yes.
Okay, thank you, Nick. Okay, the first thing is I assigned a data case number 5. Okay, I'm going to discuss the major part of this one. Okay, so you issue launch R, you issue source http data.con if.txt. Okay, so after issue this one, then you type datacase5. Okay, datacase5. Okay, and so datacase5 is about test international Fisher effect. Okay, so this is from this slide. So this is chapter 8. Okay, testing of international Fisher effect. Okay, so this is EF is change in exchange rate. So this is so F is foreign currency. So basic idea is, so this is change in direct quotation of foreign exchange rate. So left-hand side is change in a foreign exchange rate. So this is direct quotation exchange rate, direct quoted, okay? And on the right-hand side, so we have A0. So actually this is alpha, it's called intercept. So this is a beta, A1 is beta, okay? So in the parentheses, this is called X. So 1 plus IUS. 1 plus I foreign minus 1. Okay, so what is IUS? So it's interest rate, okay, nominal interest rate, IUS, okay. The denominator is 1 plus IF, okay, so ratio minus 1 plus mu, okay. So I'm going to explain this one, then I'll show you how to run linear regression, okay. So I copy paste to Excel. Okay, I copy to Excel. Okay, suppose we have exchange rate. Suppose we have a column called exchange rate. Okay, then we have a column called US. Okay, we have a column called I and foreign. Okay, and I'm going to add another column. Okay, insert. So usually this is called a date. So I use 1, 2, 3, just some specific year and a date. So this is exchange rate, okay? And so basic idea is we have to generate Y and we have generate X, okay? So we are going to generate 2 columns. Okay, I'm going to, okay, I repeat the concept, okay? And the first one, we have 1, 2, 3. Okay, our raw data should have 3 columns. The first one is exchange rate. Okay. The second one is, of course, this is called matched. It's matched. Okay. So you have to match according to date. Okay. So this is foreign exchange rate. So we have 1 column, and this is interest rate for US. So this is interest rate in the foreign country. Okay. So basic idea is based on these 3 columns, we generate 2 columns. Okay. So what is this value? So this value will be this number minus this number because this is change. Okay, I repeat. Suppose let's just use some number. So this is suppose 1.2, 1.1. Okay, so this is exchange rate. Okay, so what is Y? Y will be this one minus previous one. So this is, I think it's percentage change, okay. Regression is percentage change. Okay, so depends, okay. Alpha plus beta X. Yeah, it's change, okay. So this is a delta, okay. Delta change in the foreign exchange rate, okay. So this is, So this month exchange rate minus previous month or this quarter minus previous quarter. It depends, it's quarter or monthly. Okay. So what is X? So X will be, so this is X. Suppose I just randomly pick up some number. Okay, so 0.05, 0.06. Suppose this is 0.04 and 0.035. Okay. Okay. So let's look at the value here. The value here is equals, and another parenthesis. So 1 plus US divided by 1 plus foreign minus 1. Okay. I repeat, okay. And we have 3 columns. The first column is, so after we merge, okay, so we download the foreign exchange rate, date and foreign exchange rate. Okay, there are 2 columns. Then we download the interest rate, 2 column date and US interest rate. We download the third data set is date and foreign interest rate. So we have 3 data set, date, exchange rate, 2 column. First data set, time series. I'm going to show you how from where to download it. The second data set is date, interest rate in US. The third data set or time series is date and interest rate in the foreign country. After we merge 3 together according to date, eventually we have 4 columns. Okay, one is date, another is exchange rate of a specific foreign currency, then interest rate in the US, and interest rate in the foreign country. Okay, now based on these 3 columns, we generate 2 columns. Okay, so 2 columns is simply Y and X. Okay, so Y is change in exchange rate. X is simply 1 plus US and put in the parentheses, divided by 1 plus interest rates in the foreign country minus 1. So this is, I'm going to show the formula. Okay, so this is formula. Okay, so this is formula of this one. And I'm going to add another column. It's much. So this one will be this month exchange rate minus previous month. Okay, so let's look at the X formula. This is X. So X is exactly in the parentheses. Okay, 1 plus US interest rate divided by 1 plus foreign interest rate minus 1. So eventually we have Y column, we have X column. Okay, I'm going to show you, suppose we have Y column, we have X column. How can we get our result? Okay, so let's go back to the data case. Okay. Okay, how can we find the data? Okay, so there are 3. So first one is, so let's copy and paste. Okay, so this is 3 months, 90 days rate or yield. So interbank rates for Canada. Okay, interbank rate for Canada. Okay, the frequency is monthly. You simply click here, download. Then you can download Excel or CSV. So usually I download the CSV file. Okay, so I download it. Okay, so this is interest rate in Canada. Okay, where is? Okay. Oh, something's wrong. I do it again. Okay, so I'm going to paste it here. So just, so this is the interest rate. I download the CSV file. Okay, so this is the interest rate in Canada, okay, starting from the January 1960. Again, so this number should divide by 100. So this is percentage, okay, 100. So this is first data set, okay. Okay, so let's look at the second one. The second one will be, so this is interest rate, 3 months interest rate in the US, okay. Going to, this is identical in terms of frequency, in terms of interest rate, 3 months or 90 days rate and yield, interbank rate for the United States. Again, the frequency is also monthly. Okay, frequency is monthly. You click download, you can click download the CSV or Excel file. So this is the second time series. Okay, so let's look at the last one. Okay, so the last one is exchange rate between Canada and the US. Okay, so I go back here. I don't know what's wrong here. Okay, so let's paste it. Okay, so this is also monthly. So frequency are the same, all have the same frequency as monthly. Okay, so this is Canada US foreign exchange rate. Again, just click here, download. Oh, just click max. Oh, it's max already. Okay, then you click download. Okay, I click CSV file. Okay. Okay, so this is from 1971. So we have 3 time series. One is interest rate in Canada. Another is interest rate in the US. We have foreign exchange rate between Canadian dollar and US dollars. Okay, so be careful. This is indirect quote. Okay, it's a good idea to convert indirect quotation to direct quotation. Okay. Okay, so we have 3 time series, okay? So based on these 3 time series, we look at the date, so we merge them, okay? So we have one column called the date. The second column is exchange rate. Of course, you have to make from indirect quote to direct quotation, okay? Then we have US, we have interest rate in US and interest rate in Canada. Okay, so based on this time series, we generate Y column. So we have a column Y and we have a column called X. Now we run a linear regression. Okay, we run linear regression. Okay, I'm going to show you how to run a simple linear regression. Okay, so you click, and so I can use this data set. I'm going to use you type .ice and 28 is a simple linear regression, okay, .ice 28, okay. And run a linear regression is simple, or is almost trivial. However, how to interpret the result is more important than simply run a linear regression, okay. So step 1, generate 2 columns, so X column and Y column, okay. Step 2, click data analysis, regression, choose Y and X column, run. Then we got result, okay. So if data analysis is not available, I'm going to show you how to active or deactive data analysis, okay. The most important thing is how to interpret result, okay. So last year I generated 2 videos. One is called simple linear regression, and another one is how to replicate specific items or statistics, okay. At least, probably it's a good idea, at least you watch 1 video, okay. I'm going to show you how to run a simple linear regression, okay. And again, XY has no meaning here, okay. You can generate your numbers, okay. So let's copy and paste to Excel. So if you can launch Excel, so let's do it together. Okay, let's do it together. So we have two columns, X column and Y columns. Okay, so I go to Excel. Oh, this is exchange rate. Okay, so let's close this one. Okay, so I'm going to simply paste. Okay, we have Y, we have X and Y. And because this inside one column, we should have two columns. Okay, so I click data and you see the text to column, and I use delimit because I use comma. Okay, so I click comma. You see here, we only have one column. So if I click comma, it's automatically separated into two columns. Okay, I click next. I just click finish. Okay, so we have two columns. Okay, so this is Y column and this is X column. Okay, because we only have several rows. Okay, for the international Fisher effect, we have many rows. Okay. Okay, so let's do it together. If possible, you can launch Excel. You can copy paste this simple five pair XY, or you can simply type your own values. Okay. Okay, the first step is click data. Okay, I click data. And you see the data analysis is not available on the right-hand side. Okay, so I click file. At the bottom on the left-hand side, I have options. Okay, I click options. Okay, I click add-ins. Okay, here is manage Excel add-ins. I click go. Okay, why is not okay? I'll do it again. So options, add in Excel, and then check it. I click OK. On the top right, you see the data analysis appeared. Okay. Okay. And so the first step, and we generate two columns, X and Y. Okay. And then I click data and data analysis on top right. Okay. Data analysis. Okay. I going down here, there are some so-called regression. Okay. Click data, data analysis, regression. Just click OK. Okay. So input Y, input X. Okay, we have two columns. Okay. So click here. And so first one is Y. So this is Y. Then we click X. Okay, input X range. Okay. And I include both labels. Okay, I include both labels. Then I check labels. Okay, and your label should be change in exchange rate, and also like interest rate differential, and we can output to a new spreadsheet. So usually I choose a location. So inside some here, you just randomly choose a cell, and okay, I repeat. Okay, click data, data analysis, regression. Choose X column, choose Y column first, then X column. Okay, if you include the label, just check the labels. If you don't check the labels, and it will give you an error message. It mentions something is not numerical. Okay, and if you don't have the label, you check the label, then you are going to lose one pair of observations. Okay. Okay, just simply click OK. Okay, so this is our output. Okay, again, running linear regression is very simple. Okay, for this one, there's no specific. Okay, it's too big. There's no specific meaning for X and Y. Okay, I just want to show you how to get some result. Okay, and I think the most important thing is how to interpret your result. Okay, running a linear regression is simple, and how to get your result. Okay, and the first thing is called R square and adjust R square. Okay, and because we only have one independent variable. Okay, and so usually we can use adjust R square. Okay, so this is high. So this is what is meaning of adjust R square. Actually, it's percentage deviation in Y was explained by your model. Okay, so this is and because you see the Y, sometimes it's 17, sometimes it's 22, sometimes 25, 15. So if we can, the basic idea is we have X value. We're trying to use X value, explain Y value. Okay, so if we can use alpha, if we can use intercept, if we can use slope, if we can use Y, sorry, if we can use A0, A1, and X value to explain a Y 100%, then our R square should be 1 or 100%. Okay, suppose there's no meaning between X and Y, the R square should be 0. So R square be 0. Okay, so adjusted R square, suppose we have two models. One model we have two independent variable, and another model will have three independent variable. Okay, and if we compare with R square, the model with three independent variable is always better than two-factor model. Then we always should use adjusted R square. Okay, whether our model is good or not good, the first criteria is whether R square, adjust R square is high. Okay, if they're 100%, excellent. If 80%, very good. If like 10%, not good. Okay, the first criteria to look at the total, the quality of total model, our current model, is look at R square and adjust R square. Okay, so this is the first one. Okay, the second one is we look at independently. We look at independently. Okay, and so this is we look at the T statistics. We look at T statistics. Okay, and so there are three ways to tell. So our intercept is okay. So basic idea is alpha is 0 or not. Okay, and second one is beta is 0 or not. Okay. Okay, I'm going to. Okay, so this is our question. Okay, our question is intercept statistically different from 0 or not? Okay, I repeat. Okay, it's not doesn't mean whether this number is equal 0 or not. Actually, it means whether this 0 is statistically different from 0. Okay, I'll give you an assumption. Okay, suppose a homeless people, there's a $10 in his pocket. Okay, so what is his wealth? His wealth is 0. Okay, why his wealth is 0? He has $10. Okay, so when we're talking about wealth, and then we have some margin of error. Okay, suppose your wealth is below certain threshold, we treat as 0. Okay, okay. The first method. Okay, so this is I call the method 1. I call the range. Okay, so this is I call the method 1. So if you look at here, okay, I'm going to show you this one. Okay, if 0 is inside this 95% confidence interval, then yes, it is 0. Okay. So I'm going to put it here. If 0 is inside this 95% confidence interval, then the answer is yes. The intercept alpha is 0. Okay, so this is the first criteria. Okay, so as I use as example, okay, suppose what is the criteria for the super rich? Then super rich is you have a threshold. If above this this threshold, then you're super rich. Like homeless, your wealth is 0. Okay, then suppose your net income or net wealth is below certain threshold, then your wealth is 0. Okay, so basic idea is we have a range between 4 and 16. So this is 95. So we have a value of 10. We have a value of 10.7, 10.18. The range is 4 and 16. Because 0 is not inside this range, 95 confidence interval, then we claim alpha is not 0. Okay, so alpha is not 0. Okay, and it is also true. So we have a slope. We have slope 3.22. And so this 3.22 can be as low as 1.68, as high as 4.7. Okay, because this is not, because 0 is not inside this range, then we claim beta or slope is not 0. Okay, so this indicates our model is good because first one, the R square is 94%, adjust R square is 92%, our model can explain the 94% deviation of y. And also individually for intercept is not statistically different from 0. Okay, its value is 10. And the slope, its value is 3.22. So this is method 1. Okay, so the method number 2, we look at the p-value. Okay, because we confident, we usually choose confidence level is 5%. So basic idea is we allowed 5% chance made a mistake. Okay, I repeat the second method. Okay, the second method is, so if our p-value is less than alpha, we reject. Okay, so let's use this one as example. Okay, so our hypothesis is alpha or intercept equal 0. Okay, so our hypothesis, the intercept, we have a value 10.18, and we said, hey, 10.18, $10 is equivalent to 0. Your wealth is 0. Okay, or 10,000. Your wealth is 0. Okay, so let's test it. Let's test it. Okay, so p-value, you see the p-value? Because the p-value, okay, so if the p-value is less than 5%, then we reject. Otherwise, we accept. Okay, I'm going to show the, okay, I'm going to show the formula. Okay, and so we look at we have a value. The value of intercept alpha is 10.18, 10.18. So if the p-value is less than 5%, then we claim this 10.18 is statistically different from 0. Okay, and it is also true for the p-value for the slope. Okay, so this is the slope. Okay, we got a value 3.22 because p-value is less than 5%. So 3.22 is different from 0. Okay, different from 0. Okay, so last criteria is it's called t statistics. It's called the t value. Okay, so t value we calculate critical value. Okay, so t critical value will be t, I think is inverse 2t, and so this is 5%. So we have 5%, and degree of freedom is, so actually degree of freedom is here. So actually it's 4. It's 5 minus 1. So I use 5. How many observation? So minus 1. Okay. I'm going to show the, so this is a critical value. Okay, the critical value. Okay, so this is T critical value. Okay, so actually the method 3, type here, method 3. So method 3, if our T statistic, the absolute of T statistic is larger than the absolute value of T critical value. So this is called T. It's just I mentioned whether it's the wealth is 0 or super rich, we have some critical value. Okay, so method 3 is, so if absolute value T is larger than an absolute value of T critical, we reject. Okay, we reject. So what is hypothesis? The hypothesis is they are 0. Okay, so 0. Okay, so this is I call the method 3. Of course, these 3 methods are consistent. Okay, if you look at here, so I'm going to type, so if t stat, I use absolute value. Okay, I use, although both are positive, it seems absolute value is redundant, but absolute value ABS, so 5, suppose it's larger than ABS critical value, and we reject. Otherwise, we accept. Of course, for this one, we reject. Okay, I'm going to. Okay, I'm going to summarize about this data case. Okay, and so this data case is about test international Fisher effect. Okay, so we have Y column, we have X column. Okay, the key is whether this is intercept, whether this is a slope, statistically different from 0 or not. Okay, and also according to international Fisher effect, the slope should be positive. Okay, I repeat. Okay, if interest rate in the US is higher than interest rates in the foreign country, so X is positive. Okay, suppose this is A1 is also positive. Okay, interest rate in US is higher than interest rates in the foreign country. If slope is positive, then the foreign currency will appreciate. So this is direct quotation exchange rate, okay? So if this is negative, then we don't support international Fisher effect. I repeat, okay? There are two things we expect about slope. The first one, A1 should be statistically different from 0. If A1 is 0, so there's no relation. We don't support international Fisher effect. So this is the first one. The second one, if A1 is statistically different from 0, but it's negative, then we don't support international Fisher effect. So only when A1 is positive and statistically different from 0, then we support international Fisher effect. Okay, so this is a procedure. Procedure is we download exchange rate. We download the exchange rate, a time series. We have date, exchange rate. Then we download the US interest rate. We have two columns, date, US interest rate. Then we download foreign interest rate. We have two columns, date, foreign interest rate. We put three together according to specific year and the months. So eventually we have four columns, date, foreign interest exchange rate, foreign countries interest rate, and interest rate in US. We have four columns. We generate Y. So Y is change of exchange rate. We generate X. X is 1 plus I in US, put in the parentheses, divided by 1 plus interest rate in foreign country, parentheses, minus 1. And because we have Y column, we have X column, we run a linear regression. Okay, so based on the R square and adjust R square, we tell whether we have good model or not good model. So basic idea is whether alpha and the beta 0 or not. Okay, so actually there's another criteria is use F-test to look at the total significance of the model. Okay, so this one also developed compared with 5%. Because this value is less than 5%, we also reject. Okay, and also we look at individual coefficient. So we look at the slope, whether it's a statistically different from 0 or not. Okay, so actually intercept is less important. Most important is this slope. Okay, the slope should be, first criteria is should be positive. The second one, it should not be equal to 0. Okay, so if slope is positively statistically different from 0, we support our data support international Fisher effect. Otherwise our data do not support international Fisher effect. Okay, so this is data case number 5. Okay, I'm going to save this one, upload to Canvas. Okay, I'm going to save it. Okay, cut. Okay, this is the how to run simple linear regression. Okay, as I mentioned, I have 2 videos. Last year I generated two videos for another course. You can just watch it. Okay. Okay. Today I'm going to start the chapter 9. Okay. So chapter 9 is forecasting exchange rate. Okay. So next week I'm going to show some. I'll give you use number to forecast like SP 500. For example, what is what is your expectation in terms of SP market return? So market return in 2021. I'm going to show you several methods to how to forecast exchange, because this year 2020 is a special case. So assume it's a normal year. And what might be the methodology to forecast SP 500 market index. And similarly, we can forecast foreign exchange rate. Okay. Obviously, many firms, they forecast foreign exchange rate. Okay. And why? The basic idea, suppose it's receivable. Suppose the company will have some receivable in 6 months. Okay. They will make a decision whether hedge or not hedge. Okay, suppose the forecasting result is the foreign currency will depreciate. Then they say, hey, it's receivable, we need to hedge. So that they are going to, there will be a high probability they're going to hedge. If opposite is true, and for example, pound, our company is going to receive 10 million pound in 3 months. During these 3 months, there's high probability pound will appreciate. Okay, then the company might don't hedge. Okay, don't hedge. Okay, and common techniques used for forecasting. So forecasting is independent from the decision whether the company will hedge or not hedge. Okay, however, the company make a decision depend on their result. Okay, forecasting. Okay. And here is whether a firm hedge may be determined by forecasting of foreign currency value. Again, if we expect foreign currency appreciate, for the receivable, there's good chance they don't hedge. For payable, then they have a high chance to hedge. Okay, so this is a decision whether hedge or not based on their forecasting. Okay. Okay, so this is a large deposit can establish in several currency. Okay, it's short term, it's related to cash. Okay, capital budgeting decision. So usually this is long term. Okay, it's long term, maybe 5 years, maybe 10 years. Short term usually is 1 year. Okay, maybe around 1 year. Okay, so this is if you have a lot of cash, receivable, accounts payable, the short-term decision is more important. The short-term forecasting is more important. Okay, so if you have the long-term capital budget decision, then long-term forecasting is more important. Okay. Okay, so this is earning a foreign currency remit. Okay, and suppose you suppose based on your forecasting result, the foreign currency going to appreciate, then you will delay to remit the foreign earning. Okay, and opposite is also true. If you expect foreign currency will depreciate in the, for example, in 6 months, then you should remit as soon as possible earning. Okay, and the long term is related to the borrowing. Okay, I think this is sometimes crucial. Okay, so if you expect Canadian dollar will appreciate in the long run against US dollars, then it's my good idea you borrow Canadian dollars. Okay, it is opposite. It's also true. If you expect Canadian dollar will appreciate against US in the long run, then you borrow US, you convert to Canadian dollars. Okay, because in the future you pay back US dollars, and relatively speaking, and Canadian dollar will be stronger in the future. Then you can extra profit or benefit. Okay, so this is why the company conduct to forecast foreign exchange rate. Okay, and so basic objective increase dollar cash flow. Okay, and reduce cost of capital. Okay, for this one usually is short term. Okay, short term and long term. Okay, and so this is hedge. I repeat. Okay, so if foreign currency is cash inflow, so our concern is foreign currency might depreciate. If our forecast confirm the foreign currency might be depreciate, then we are going to hedge. Okay, if opposite is also true, our forecasting based on our forecasting result, the foreign currency will appreciate, then there's good chance we don't hedge or only hedge partially. For example, 10 million, we hedge 5 million. Okay, so this is if it's accounts payable, then we will have the opposite result. Okay, for the long term, the cost of capital is like a capital budgeting. Okay, I repeat. For the short-term decision, it usually involves receivable, payable, inventory. We buy raw material from foreign country or we pay. It's short-term. Okay, we forecast short-term, 6 months, 3 months, 1 year. For the long-term is long-term investment. So we have a project lasts about 20 years. Then we will forecast whether we borrow Canadian dollar or British pound better, or we borrow US dollars loan better. Okay, so this is the incentive. Okay, and technical forecasting, fundamental forecasting, and market-based forecasting, mixed forecasting. Okay, and okay, so this is a simple category. Okay, and when we for financial analysts, when they analyze performance of the firm, okay, suppose is IBM good or Walmart or Tops? Okay, Top, I think Top is private company, right? Suppose Walmart versus IBM, okay, and so usually there are two big category. One is called technical analysis. Okay, so technical analysis based on historical data. For example, the price movement, trading volume, and price high, price low, and so depend on historical data. So this is called technical analysis. So this is first big category. I'm trying to explain the technical forecasting. Okay, so this is it's almost identical to the technical analysis for the common stocks. Okay, the second one is called fundamental analysis. So let's go back to the first slide. Okay, so the first category is called technical analysis. We don't look at the companies whether it's we don't look at the industry. We don't like who is CEO. We don't look at the like accounting data in the past 5 years, 10 years. We don't look at the product. We don't look at the credit rating. We only focus on the trading data. So this is called technical analysis. Okay. The second one is called fundamental analysis. The fundamental analysis is opposite of technical analysis. They look at, for example, IBM. Who is CEO? What is performance in the for the company in the past 2 years, past 5 years, 10 years? What will be their current ratio? What will be their ROA, return on assets? What's their ROE? What is industry? Who are their competitors? What are their products? And what is the industry performance? So fundamental analysis is look at everything. Okay, so I'm trying to use the stock market to explain these two big categories. Okay, so technical forecasting is simply use exchange rate data to predict future value. Okay, we look at the 2-time series or 1-time series, and for example, Canadian dollar versus US dollars. We don't look at what is potential and political issue in Canada or political issue in US. We don't look at like Biden's whether it's the 2 trillion construction plan or not. Okay, so this is called technical. Okay, and so technical only for the short term, of course, it's only for short term, limit to usually it's less 1 year. Okay, and also there are some like period specific. Okay, because we have the like business cycles. Okay, and so when the economy is expanding, is quite different from recession period. Okay. And so this is called the weak form efficient. Okay. And because there are a finance professor at Chicago University, he proposed 3 forms. Okay, weak form, semi-strong, and strong. Okay, so what is weak form? Weak form is simply we cannot. Okay, I repeat. If stock market is efficient in terms of weak form, its conclusion is we cannot use historical data to predict future. So this is meaning of the market. So if the foreign exchange market is weak form, so this indicates we cannot simply use historical data to predict future. If this is true, then we cannot use technical forecasting. Okay, the fundamental forecasting, so actually it's based on the economic variable. Actually economic, political, and plus exchange rate. Okay, and here is purchasing power parity. And suppose we have data from 2 different countries about their gasoline consumption, the price, this is CPI, and they also like grocery, and there are some most used the price. We compare and we use weighted average, then we can forecast. Okay. And fundamental analysis with a lag. Okay. So the lag, it will be delayed. Okay. Suppose some oil producing country, they increase the price or they reduce the price, then the impact might be delayed. Okay. 3 months, 2 quarters. So this is delayed. Okay. Okay, so instantaneous influence in fundamental forecast. So actually it's because of the delay. Okay, so usually it's look at the long term instead of the short term. And so actually for this one is quite identical to the previous one. Okay, and so this is called a comprehensive model. So if we have such a model, okay, what might be possible factors? Okay, and so this is almost identical to previous function format. Okay, so this is change foreign currency, maybe appreciation, depreciation. It depends change the inflation rate. So So this is inflation rate differential, the first one. Interest rate differential, income differential, government control, and expectation. So expectation. Okay. And so these are 1, 2, 3, 4, 5. Although we only have 5 variables, okay, sometimes it's quite difficult to quantify. For example, as I mentioned, the government control, okay, itself, the government control itself is difficult to quantify, and let alone change in government control. Okay, so this is just like a model. Okay, and there are some also limitation in terms of fundamental forecasting. Okay, and timing, delay, whether we are in the recession, expanding, what might be the delay of the fundamental factors. Okay, and so this is one is difficult to get. Okay, unlike technical analysis, we can easily download like foreign exchange rate, like Canadian dollar versus US dollar, British pound versus US dollar, or even some cross exchange rate. It's easy. It's only a 1-time series, maybe 2-time series. Okay, then suppose for the cross exchange rate, we have US dollar versus British pound, we have US dollar versus Canadian dollars, then we can calculate cross exchange rate in terms of pound and in terms of Canadian dollar. then we can forecast the cross exchange rate. It's very simple. We only have 1 or 2 time series. Then we can conduct our test. For the fundamental analysis or fundamental forecasting, it's not that easy. The most difficult part is data. The first one is availability of the data. The second one is how to clean your data. Okay, how to clean your data. So I think these are two most difficult part in terms of data analytics or forecasting. Okay. And so regression coefficient will not remain constant. Just like when we look at international Fisher effect, if some researcher or practitioner, they want, I didn't ask which time period, okay? So if they want to make a very good model, okay, then they should cut the whole time period into several sub-periods. For example, when economy is expanding, when the economy is recession, or when the economy is normal time period, if they cut like into different category, then they have a much better result. Okay, so this is a regression coefficient. So in terms of international Fisher effect, we calculate alpha intercept, we calculate slope beta, and depend on different time period, alpha and the beta might be different. Okay, might be different. Okay, so this is fundamental. Okay. And so another one called the market-based forecasting, okay? And so this is spot rate, and today's spot rate may be used to forecast of the spot rate of future data, okay? So what is, suppose, what is today's exchange rate today, okay, for the between US and Canadian dollars, and what is 3 months later, okay? So naive forecasting is, and today the future spot rate in 3 months is same as today's spot rate. Okay, so this is I call the naive method. Okay, so tomorrow's data, so tomorrow's value is same as today's value. Okay, and so another one is, so this is another one is use forward rate. Okay, because forward we today we observe today. Okay, so expect spot rate equals forward rate divided by S minus 1. Okay, and suppose forward rate is 10% higher than spot rate, so the ratio will be 1.1. Okay, 1.1 minus 1 should be 0.1. So the foreign currency will appreciate against local. If this ratio is negative, then we expect the foreign currency will depreciate. So this is based on the market expectation. The basic idea is if the forward rate is the same as the spot rate, then we expect the future spot rate will be same as today's spot rate. If 3 months forward rate is higher than today's spot rate, then 3 months spot rate expect to be higher than today's spot rate. So this is basic on, it's called market-based forecasting. Okay. And so what is p-value? It's percentage by which forward rate exceeds spot rate. Okay. And so this is, again, so this is not E itself, it's not exchange rate, is percentage change. Okay, so this is its percentage change. Okay, so again, it's good idea use delta E, the percentage change. Okay. Okay, so we have some, we call, so basic idea is we use forward rate because we observe forward today. We observe both spot rate and forward rate. Then we can use forward rate, the relationship between forward rate and spot rate to figure out what is market expectation. Okay, so this is the logic behind why we can use forward rate to forecast. And so international Fisher effect, okay. And So basic idea is forward rate capture. Okay, why forward rate is higher than spot rate? Because we observe, suppose US interest rate is higher than foreign country. Okay, so this is, we use market-based forecasting. So actually it's based on international Fisher effect. Okay, because international Fisher effect. Okay, 5 more minutes, so slides. Okay, sometimes called the mixed forecasting. Okay, and so mixed forecasting basic idea is, so actually most professional researcher, it's like believe. Suppose I have 5 methods. I have 5 different methods to forecast, suppose IBM stock price at the end of 2021. I have 5 methods. Okay, so what is my final result? Okay, and the simplest one is I can use average. Suppose one said it's 120, another one 150, some 200, and so I use like average. Okay, so this is first method. The second method is I use median. I don't use average because I can, if some method give us some extreme value, okay, and then this extreme value have a very strong impact on the average. And some research use median, okay. And suppose I have 5 value, I sort them from highest to lowest, I choose number 3. Suppose I have 10 value, I have 10 method, then I sort them from highest to lowest. I use average of 5 and 6 as my final result. Okay, so this is called mixed forecasting. Okay, and some use average, some use median, and some use, you said, hey, I have 10, I remove top 2, I remove bottom 2, then I use the 6 forecasting value, average. Okay, so this is the second one, a third one. And another one is called use weighted average. So weighted average is, and suppose I use different weight. Okay, I use different weight. And suppose I only have 2 methods. I have only 2 methods. At the very beginning, I give equal weight. So 50-50. I look at the result. I give the method 1 60% weight. I give the method 2 40%. I look at the result. Okay, so actually I have to measure the performance. Suppose I find if I give more weight to method 1 and compare with method 2, my result is more accurate. Then the next period, I'll give more weight to method 1, give less weight to method 2. Okay, so this is called weighted average. So based on our performance, then we decide, give one method more weight and give less weight to another method. So this is called weighted average. Okay, so basic idea is we have several methods to forecast. So this is first one. So next week I'm going to show you several examples. We have several methods to forecast stock price, expect return, micro return in 2021, or exchange rate. So this is the first step. I think the second step is more important. The second step is how to measure. Suppose we have 3 methods to forecast exchange rate. Then we look at we call measurement error. We look at, there are also several methods to measure forecasting error. I say exchange rate is 1.2. If realized exchange rate is 1.2, then forecasting error is 0. If forecasting exchange rate is 1.3, the forecasting error is 0.1. And then we calculate like 10 months or maybe 2 years monthly forecasting error. Then we can calculate the average, we can calculate maximum value. Okay, then based on the forecasting error, then we decide which method is better or the best. Okay, I think I stop here today. Okay. Um, Again, I assigned the new data case is test international Fisher effect. Okay. The due date will be next Thursday. Okay. If you have any issue, let me know. I'm going to have an office hour this afternoon at 3 o'clock. So if you have any issue with the data case or with this chapter, please join me via Zoom. Okay, I stop here today.
Thank you.
Thank you. Thank you.